ground starts to quiver, glasses rattle. Soon walls shift and everything begins to collapse. Telltale signs of what could be a devastating earthquake. We've seen the destruction they unleash. Some of us may have even lived through one. And we know it can be deadly. But where does this mountain-moving force come from? While we may think we're standing on solid ground, the earth beneath us isn't completely stable at all. Our planet's crust is made up of about 12 major tectonic plates that fit together like a giant jigsaw puzzle. These huge slabs of land float on superheated magma and constantly shift, bump, and grind against one another. It's there, along the seams, where earthquakes tend to happen. When friction between the two plates is violent enough, seismic shock waves ripple through the ground, rattling everything that stands on it. The stronger and shallower the quake, the more violent the destruction. The most violent type of earthquake is born in a subduction zone, where one tectonic plate is shoved beneath another. While one plate is forced downward into the mantle, the other jets upward, often violently. This is the type of quake that rocked Nepal in May 2015. And when subduction happens under the ocean, it can create giant, unstoppable waves called tsunamis, like the ones that killed hundreds of thousands in Japan and Indonesia. On average, earthquakes kill about 10,000 people each year. Sometimes numbers are far higher. The quake that hit Haiti in 2010 killed more than 300,000 by some counts, making it one of the deadliest on record. It is estimated that there are 500,000 detectable earthquakes in the world each year. 100,000 of these can be felt, and 100 of them cause damage. That's about 0.1%. The magnitude of an earthquake is measured using the Richter scale, which runs from 0 to 10, 10 being the strongest. Every whole number increase on the scale means 10 times more ground motion change. In recorded history, the world has never experienced a 10 on the Richter scale, but scientists predict an average of at least one major quake of magnitude 8 or higher every year. The fact is, the Earth's crust is restless and always on the move. We can't see earthquakes coming, but we can prepare for them. Engineers are now designing stronger buildings, resilient enough to survive a direct hit. Scientists are crunching data to project the power of future quakes and anticipate when and where they could strike next. Right now, we can only estimate the probability an earthquake will occur, but perhaps one day we will learn to predict them, minimizing their destruction and saving countless lives.
All right, you're going to keep watching. I have another video to show you. So I'm going to click on this one, and here we go.
Supervolcanoes are the most...
Uh-oh. Hold on, it's reloading. Oh, here we go.
Supervolcanoes are the most violent and complex class of volcanoes. But despite their destructive capabilities, they can also make way for life renewed. Around 20 supervolcanoes are scattered across the planet. They're usually characterized as large depressions in the ground called calderas, located above multiple openings in the Earth's crust. In terms of eruptions, supervolcanoes explode at a magnitude of 8, the highest and most violent classification on the Volcanic Explosivity Index. Supervolcanoes undergo a life cycle of 3 major stages: a surge of trapped magma, a supereruption, and a resurgence. The first stage of a supervolcano's life cycle involves a pocket of magma trapped under the Earth's crust. Called a hotspot, this magma reservoir is fed by a pipeline deep into Earth's molten interior. It grows and builds pressure underground, eventually causing the crust above to be pushed upward. The supervolcano Campi Flegrei on the west coast of Italy has pushed the ground up several times over the past few decades. At one point, within a matter of only 2 years, enough magma accumulated to cause the ground to swell up to 6.5 feet. The next stage of a supervolcano's life cycle is a supereruption. At this point, the buildup of pressure in a magma reservoir hits a critical mass and then explodes, sending over 1,000 cubic kilometers of tephra, or ash and rocky material, into the sky. The most recent supereruption occurred in New Zealand approximately 26,000 years ago. The supervolcano Taupo ejected about 1,100 cubic kilometers of tephra into the air, enough material to constitute nearly 500,000 Great Pyramids of Giza. After a supereruption, a supervolcano undergoes a stage called resurgence. Having dispelled its contents, a supervolcano's magma reservoir collapses and forms a caldera. The Yellowstone caldera in the United States is currently in resurgence after a supereruption occurred about 640,000 years ago. In the time since, freshwater collected in the caldera to form a lake. Plants and wildlife returned to reclaim the space, and some of the world's largest geothermal features emerged. Supervolcanoes have created unparalleled natural beauty, all in the wake of some of the world's most cataclysmic events.
All right, you're gonna keep watching. I'm gonna show you another video, possibly two, so just be patient, okay? Okay, that video was about supervolcanoes, kind of extra information. This one's going to be about just volcanoes, kind of things that we've been talking about as a result of the tectonic plates moving. So here we go. It might reload again. Oh, wait, hold on. Okay.
Our planet has a violent soul. Majestic and often destructive, volcanic explosions rattle our collective imagination. Krakatoa, Mount St. Helens, Etna, Eyjafjallajökull, the images simultaneously strike fear and awe in our hearts. But how did these giant mountains form, and where does all that destructive force come from? At least 50 eruptions rock the Earth each year, meaning our planet is literally bursting apart at the seams. The Earth's crust is made up of about 17 slabs of land called tectonic plates that float on the superheated magma that makes up most of the planet's interior. Magma is the Earth's lifeblood, churning restlessly beneath the crust. And wherever it can, it's trying to burst through. It's at these spots that volcanoes form. Our planet is home to some 500 active volcanoes. While some volcanoes, like those in Hawaii, break through a thin point in the crust called a hotspot, the vast majority of volcanoes occur on active fault lines where tectonic plates meet. The most volatile region is the Ring of Fire, a geological fault belt that rims the Pacific Ocean and holds roughly 75% of all the Earth's volcanoes. Typically, volcanoes take one of two forms. Shield volcanoes, wide and broad with lava usually slowly oozing out of them, and composite or stratovolcanoes, steeper and more violent. When hot liquid magma reaches the surface, whether in a slithering flow or a booming eruption, we call it lava. Though molten lava may seem threatening, it's not known to move quickly. A volcano's pyroclastic flow is far more deadly. This poisonous ash cloud can race down the slope of a volcano like a bullet train, obliterating everything in its path at speeds topping 100 miles per hour. It's what stopped the residents of Pompeii dead in their tracks. But despite the volcano's brutal destruction, it is also a force of beauty and rebirth for the planet. Lava creates new lands where life can flourish. Like it or not, volcanoes are part of the planet's life cycle. As the Earth continues to explode, gurgle, and slither its molten heart out, we must learn to live side by side with its awesome power.
Okay, you're going to watch one more thing. Okay, this last video is going to be a CBS morning news story that was very recent. It was from March 8th of 2017. So just about 3 years ago, a little over. but it's kind of interesting to learn about the San Andreas fault line that I had told you guys about. Um, so here you go. This guy in the video, he does have a funny name. He's a very bright scientist, and I've seen him on the Science Channel a bunch of times. So here you go.
Geologists are out with a very startling warning that Southern California is overdue for a major and possibly catastrophic earthquake. A new study says it's expected to hit along the San Andreas Fault north of Los Angeles. It could have a magnitude of 7.5 or higher. That's big. For the first time, scientists are closer to knowing when it could strike. CBS News science and futurist contributor Michio Kaku is a physics professor at the University of New York City. Good morning to you, Professor. When I went to see you in the green room, you said, I'm here with doom and gloom. But let me tell you, I grew up in high school and junior high. We've been hearing about an earthquake coming in California for years. What makes this different?
Well, before it was all hocus pocus and black magic predicting earthquakes. And I was born in California, 10 miles from the San Andreas Fault, living under the shadow of the big one. Now we can quantify this. And we now know that the San Andreas Fault is locked, loaded, and ready to rumble. We now realize that the people of Los Angeles are living on borrowed time. We now know that by digging into the soil, we can go down 1,200 years into the past, looking at soil laid down hundreds of years ago, and we find 10 major earthquakes in the last 1,000 years. The difference in time is roughly 100 years on average. The last big one was 160 years ago. So according to one calculation, we're 60 years overdue for another big one.
You're talking about the great 1857 quake, right?
That's right. It was a huge 7.9 earthquake that was so big it actually liquefied the soil north of Los Angeles, like halfway between Bakersfield and LA.
And the tremors in that quake, by some reports, it lasted up to 3 minutes. Is that right?
Yeah, so we're not talking about just a few seconds, like maybe in a Northridge type earthquake. We're talking about an earthquake that lasts for minutes. And also the U.S. Geologic Survey did an estimate of property damage. What could happen if the 1857 earthquake happens today? The numbers are frightening. $200 billion in property damage. That's billion with a B. 50,000 people injured. 5 major skyscrapers toppled because of a gigantic earthquake, 7.8 in this study.
Well, you're not sweetness and light this morning with the information you're giving, but it is important. So if people who live in that area, what would you recommend them to do other than freak out?
First of all, don't panic, because the next big earthquake could happen decades from now.
That's counterintuitive. Professor.
We don't know precisely when. Seismology is not a predictive science. However,
don't panic.
Schools. I think schools should have a special session to teach their kids what to do, where to go, how to communicate in the process of an earthquake. Families should meet with everyone in the family. Do you have batteries, first aid kits, water, food? Who do you contact with? Do you have like a radio, a transistor radio? Little things like this.
They should have that.
They should have that. Right now. And then longer term, building codes have to be accentuated, I think. And also power lines have to be reinforced and redundancies so we have power and buildings don't collapse unnecessarily.
You're saying we may have decades, though. I mean, the energy's been building up, but it could be, I mean, we could be another 10, 20, 30 years.
It could be tomorrow. It could be decades from now. We just know that the San Andreas Faults have been moving at about an inch a year. So it's like winding up a clock. It gets tighter and tighter. An inch a year is the rate at which it's been tightening.
Wow.
And therefore, it's a law of physics. All that tension has got to go someplace. And so it's not a question of if, it's a question of when.
Well, Michio Kaku, always great to have your expertise this morning, however scary. Sometimes it's asteroids and meteors. Today it's earthquakes. Thank you.
All right, well, that's it. Make sure to go answer your question on Canvas.